Hey folks, welcome back for another episode of Code Club. In today's episode, we are going to be building a heat map that I found on the New York Times website back at the end of December. Now, this is the article that it came from, and if you recall, I talked about this in the last episode and how I couldn't get the underlying data. And so we had to spend the last episode a lot of time extracting data from the heat map. So let me just reintroduce you to this article if you haven't seen it, but the title is How Drug Overdose Deaths Have Plagued One Generation of Black Men for Decades. And so again, one of the things I really liked about this was that it had this kind of scrolly telling aesthetic where my finger is continuing to scroll and you see the plots update and text going over the plot are updated. And it just kind of keeps going and kind of showing context for different types of mortality among Americans as well as Black men, and specifically within Chicago. And so this is the heat map that I wanted to make, but as I said, I couldn't get the data. And so they have a reference down here to the NCHS mortality data. So a lot of that is going to come from the government. And I think ultimately the Times and the other news outlets that they were working with did a fair amount of statistical analysis on the data to generate the data going into these heat maps. I reached out to them. I wasn't able to get the data from them. They never replied. Oh well. So again, in the last episode, I talked about how we could extract the RGB, the red, green, blue value for each of these rectangles, and then how we could correlate that with a number of deaths per 100,000 people using the legend in the lower right corner. Because that took so long, I couldn't recreate the actual figure. I could only recreate the data, and I'm really kind of approximating the data, right? So again, in today's episode, what I want to do is work with you to recreate this image in R. We will use the tidyverse as well as show text to get in the font that the New York Times use. They use a version of Franklin. We can get access to Franklin using Google Fonts, and so we'll do that. And so I think this will be a lot of fun because I know heat maps are very popular among scientists and increasingly among media, where on the x-axis we might have one continuous variable and the y-axis another continuous variable. And then we populate the values of those cells or those combinations with different colors, and the color then shows the intensity or the elevation of a specific value. In this case, looking at the number of deaths. One challenge with heat maps that you have to be aware of, however, is that we do a very poor job as humans in interpreting color, right? And so, you know, if I think about, say, this rectangle here that my cursor is pointing to, I'm not really sure where that falls here on the legend. I know it's less than 400. I think it's a little bit above 200, but is it 250? Is it 300? Or are my eyes wrong? It's like 150, right? It's really hard to map the differences in intensity of the color back to some continuous scale, which is unfortunate because that's exactly what they're trying to do with color. Anyway, I think it does tell a story though, where you can kind of qualitatively see the intensification of the color kind of going up and to the right, and specifically between about 2015 and 2022 here, and that it's most intense among men born between 1951 and 1970. Beyond the heat map, there's a few things here that I'm really interested in. So they have these lines, right? So we're putting lines on top of a heat map. I think that's pretty cool. They also have a color scheme that I'm not familiar with, so we'll have to come up with something. Also looking at their legend, their tick marks go all the way across the gradient legend. And so if you're familiar with gradient legends in ggplot, you know those tick marks don't usually go all the way across the gradient. So we'll have to figure that out. Also, as always, New York Times has their own kind of style, right? And so they have these tick marks that aren't connected to the axis. They set back a little bit. And the axis title, at least for the y-axis, is up here in the upper left corner. And there is no axis title for the x-axis, because I think that's obvious that that's the year. Finally, they do really nice styling, I think, in the title and using differences in font face, right? Where they have bold for drug deaths and Black men, and then a plain font for in Chicago among, okay? This is the version that I pulled off somewhere. I'm not exactly sure where I got it from. I think maybe it was from an email newsletter, or I don't know, maybe I was looking at the page in a more narrow format than what I had just shown you. Regardless, this is what we're going to try to recreate today. So here in our studio, I have a stub of some R code. All of the R code that I'm going to be generating today, you can get down below. In the description for this episode, you'll find a link to a blog post. You can go there and I will show you all of my code. So I am going to be loading the tidyverse as well as show text. As I mentioned, the New York Times uses a Franklin font for their sans serif font. And so we're going to go ahead and load that from Google Fonts. So I'll go ahead and load all this to get things going. I also have a Chicago drug deaths.tsv file. I'll provide a link to that down below as well, if you don't want to go through everything I did in the last episode to regenerate that. And so we can read that in now as read TSV, and it'll be Chicago drug deaths.tsv. And we see that that is a rather lengthy file, right? 2,890 rows, 3 columns. And so we have the year, the age, and the N. Now, again, my N is not the exact value that the original authors used. It's my extrapolation from the heat map that they published and cross-associating that with their legend. All right, so let's go ahead and make the heat map. So we can pipe this to ggplot, AES for our aesthetics. On the x-axis, we're going to put the year. The y, we'll put the age. And then the fill will be the n. And then to plot this data, we'll go ahead and do geom_tile. And then I have this ggsave statement here that is set for a width and height to match the aspect ratio of the version I had previously shown you. That is our heat map. We can see that it's quite a bit different, so we have a ways to go to make ours match the original New York Times version, but qualitatively we can see that we're on our way, right? So there's this very dark rectangle where my crosshairs currently are, and that maps pretty well to this rectangle here. So why don't we go ahead and do the big lift in trying to match their color scale. To match that color scheme, we're going to do scale, fill, gradient, N. And again, if we run that, it complains because there's no colors. I haven't used scale, fill, gradient, N very often. There's a couple of scale gradient functions. So there's gradient, which is basically what they've given us by default. It goes from black to blue, right? And so you can kind of see that that's the low and the high are the colors that we're getting there, right? Scale color gradient 2 allows you to have a low value, a high value, and a mid value. This would work well for, I've often seen it with like gene expression data, right? Where you have like no change in gene expression would be in the middle, be white, increase in expression be red, and a decrease would be blue, right? That's a very common motif that you'll see in heat maps for gene expression. Then there's also scale color gradient N, where you want to insert more than one color. Now, as I scroll down, I know that there's a variety of palettes for this scale fill gradient N. And what I'm thinking of is that this looks a lot like the Viridis color scheme package. Instead of going straight to scale fill gradient, let's do scale fill Viridis, and let's try C because we've got continuous data. And so this is the classic Viridis color scheme. If I go to the help for scale fill Viridis C, looking through here, so D is for discrete data, C is for continuous data, and B is for binned data. And so there's a variety of options that we can use. So I think the default is option D. And so option D down here is the Viridis, okay? So let's see what this looks like with A, B, C, E, F, G, and H to see if we might be able to match what color scheme the New York Times is using with one of these Viridis options. So we'll do option equals A. All right, so that's not the color scheme we want, I don't think, but one thing I'm noticing right off the bat is that the color scheme is flipped. So we can come in here and do direction equals -1, and that will then flip the direction. And so this looks actually fairly close to what we have, but ours is a bit more yellow than theirs, right? Theirs is more of a off-white or ivory. This is just looks very buttery yellow. Sorry, I'm not very good with color, so accept my descriptions, okay? All right, so let's try option B. And if anything, that seems more yellowy for the background. Let's try C. That's a brighter yellow. Noticing a trend here. That's even more yellow and kind of brings out some of the green. I think we're kind of losing it. So E. Yeah, that's not what we want. F. This kind of comes back to what we had although the background is a little bit too reddish now. And then let's try G, that's more of a green background. And then H is more of a rainbow. Rainbow is bad. You want to use a rainbow color scheme. All right, so we didn't find what we wanted within the scale fill Viridis. So I'm going to go ahead and remove that, and we'll return to the scale fill gradient N. So similar to this episode where I'm giving you all the code, I've also given you the code for the last episode, and I'll put the link again down below in the description. And so if you scroll through here, you'll see the code that I posted and how I went through looking at this legend to find the 0 point and then various points like say 50, 100, 200, 150, and so forth, and then matching that position to the RGB, the red, green, blue hex code for that color. And so rather than redoing all that with you, I'm going to go ahead and grab what I used as my arguments for colors and values within scales pal gradient N. This is the function that's used under the hood for the scale fill gradient or scale color gradient N types of functions in ggplot. So let's go ahead and copy this, and I'll go ahead and plop that in here. And so now we have our colors and our values. Let's see what this looks like. And so that gets me a lot of nothing, right? This looks basically like the 0 background. So let me go back to the documentation for scale fill gradient N. And so let's look at the arguments in its usage, which will be right here, right? And so we have colors and values. So I wonder if my values aren't quite right. So let's scroll down and look at values and come down here. Great. So if the colors should not be evenly positioned along the gradient, this vector gives the position between 0 and 1 for each color in the colors vector. So these values need to be between 0 and 1. My minimum value is 0, so that's the 0, and my maximum value is 735. So if I divide all of these by 735, then I should get the range that I want to be between 0 and 1. That did it, right? We now have the same 0 background as what they had, and then we see the pretty intense colors in more recent years for men between the ages of about 50 and 70 years old. Cool. So we have successfully matched the color using scale fill gradient N. If I were designing this plot myself, I probably wouldn't be using such a complicated color scheme. I would probably use something like a scale fill gradient and give kind of my minimum and my maximum values, perhaps going from something like this to this. Let me show you what that looks like just so we can get a sense. So if we did scale fill gradient and we did min equals this, actually I think it's low, right? Low is the argument. And then I think high is the upper argument. So then if we take this and plug that in, I'm going to go ahead and comment this out for just a minute. So let's again see what the heat map would look like with a very simple model for describing the change in number of deaths with color. And so what we see is that it's basically kind of a purplish color scheme, and it leaves out the red. And so I feel like what they're doing here is kind of part of the rainbow, right? They're expecting you to understand that when something gets hot, it turns purple, right? Which is probably not what we really want. So I think one thing that I've noticed is that in this upper scheme to kind of the right above 400, the colors are all very similar to each other. And we can see that by looking at the colors in the colors vector, right? That these last 5 values, which go from like 400 to 735, are kind of indistinguishable, right? And so there's not a lot of differentiation up in those purple colors. And so to me, what that's saying is that don't worry about the differences here. They're really similar to each other, and they're actually really high. Whereas the lower range from like 400 down to 0, that's where a lot of the dynamic range is here in the heat map. So again, that's a bit of a design choice that they made to highlight what they wanted to show in the data. So we'll go ahead and remove that scale fill gradient, and now we have something that looks a lot like what they had in their version of the plot. I think the next thing I want to do is go ahead and take our legend and move it to be in the lower right corner. So let's go ahead and do that. And here we can then do theme. We can do legend.position equals bottom. And we see that our legend is, of course, now at the bottom. I would like to have a title. So theirs was deaths per 100,000. So I could do that in labs, or I could do that here in scale fill gradient N. let's go ahead and do it in labs because we're going to be using the labs function for our other titles. And so we'll do fill then equals deaths per 100,000. And while I'm here, I'll go ahead and do x equals null to get rid of that x-axis title. And so now we see that's gone, and we have our legend at the bottom. But you'll notice that theirs is right justified on the heat map, whereas ours is more or less centered. So to get it to be right justified, what we could do would be to do legend justification.bottom, and then we can say right. And so that's going to take the legend at the bottom and right justify it on the plot. So now we see it's right justified, but there is a bit of a margin there. I'm going to go ahead and turn off the expansion on the plot so that we can get a better sense of that justification. So let's go ahead and do chord Cartesian, and I'll do expand equals false. And I don't know that I need it, but I'll also do clip equals off, add that in. And so now that blows it out. And we now see that there is a bit of a margin. So if I take my crosshairs and go up, I see that there's a bit of padding to the right side of my legend, where again on theirs, I think that's like dead on, right? So we should go ahead and remove that right margin on the legend. And so I'll do legend.margin equals margin, and I'll say R equals 0. So the right-hand margin should be 0. And so now I see that that is right justified on the right side of the heat map. Again, one thing I notice is that their tick mark on the legend goes all the way across, whereas mine just kind of digits in, right? And so to get that to go across, we can also modify that in the theme function using legend.ticks.length. And so now we can give it unit and a length, right? And so let's go ahead and do like 10 pt, 10 points. And so now we see that it goes all the way across, and we could make it thicker or narrower using the legend ticks argument using the element line function, right? But we'll see if we need to do that here in a bit. So the next thing I want to think about doing with our heat map legend here is maybe making it not so tall and to make it wider. And we can do that again back here in theme. We can do legend.key.height, and let's go ahead and do unit, and let's do 5 points. And so that makes it a lot shorter. And so that looks a lot like what they had in theirs. So we also want it to be longer. So to do that, we can use the legend key width. So we'll do legend key width unit. And I don't know what this should be. So let's try 5 points and see what that gets us. Okay, so that got it really narrow. So let's go ahead and up that to 15. Okay, so that's wider, yes. Let's try 25. And so that goes to the left of our 2010. And while we don't have everything locked down in terms of the space, maybe we can kind of measure the length of theirs. So theirs was 500, and ours, if we measure that, is 513. Let's take this down to say 24 and remeasure. And I think we're going to be pretty close. So 490. We can't do too much better than that. So let's go ahead and think about the title of our font to be a smaller size. And so again, we'll do legend.title, and then we'll do element text, and we'll do size equals, let's do 7 to be a little bit taller than the height of our legend. And let's also do family equals, and I think I called it Franklin. Yeah, Franklin. So we'll go ahead and plug Franklin in here. So I think that's pretty good. We want it to be moved up to be justified with the actual legend. So I wonder if we can do vjust equals 0. So that moved in the opposite direction from what I wanted. I always get vjust 1 and 0 mixed up. So I think we want 1. So that moved it up to be justified with the ribbon. That's pretty cool. So let's go ahead and modify the text on this. So one thing I noticed right off the bat is they don't have a 0, whereas we do have a 0. So we'll modify that back up here in scale fill gradient n, where we can do labels equals, and then we'll go ahead and do 200, 400, and 600. And then we also want to put in the breaks. So we'll do breaks equals 200, 400, and 600. I don't know that I need both labels and breaks, but let's just do it to be safe. So now we have 200, 400, and 600. Let's go ahead and shrink that font down a bit. And we can, of course, do that using the theme function. We'll do legend.text, and then we'll do element text. Let's do size equals 5, family equals Franklin. So I think that font is too small. So let's go ahead and bring that up, and maybe we want 7 again. Maybe we'll just take it down a peg and do 6. So there appears to be a bit of margin now between our text and the ribbon. So let's see if we can't move that up. And I'm not sure where the margin is, so let's try it in legend text first. And we can do margin equals margin, t equals 0. Okay, that's where it was. So we want a little bit of margin at the top. So let's go ahead and put in, say, 3. Cool, I think that's pretty good to bring it down a bit. So I think this legend looks pretty good. It does a pretty good job of replicating what they have in theirs. The next thing I want to do is turn our attention back to the heat map. And one thing I notice is that they have an appearance of like a grid overlaid on top of their heat map to kind of separate the different cells. And so I'm going to go ahead and add that using the color aesthetic from geom_tile. And so with geom_tile, fill is the interior color, whereas color is the exterior color, the edge, right? We can do color equals white. Now we have those white borders giving us the same kind of grid aesthetic that they had in theirs. And so I think this is looking really good. Now what we can do is go ahead and add these lines showing the cohort over time. To do that, we can use geom_ab_line. So we'll come back up here, and after geom_tile, because we want it to be on top of the heat map, we'll do geom_ab_line. The arguments are going to be intercept and slope. And so our slope is going to be 1, because for every year, you're going to get 1 year older, right? The intercept, I think, is going to be harder to think about, okay? So this is going to go back, and it'll be 0 at 1951, right? So the men born in 1951 were 0, but we want the y-intercept, not the x-intercept. So I think it would be minus 1951 and minus 1970. So we'll do minus 1951. So let's try one line, and then we'll add the second. Very good. So that is our upper boundary on the cohort, and that seems to match perfectly what they did. So now we want to do the second line, and we can do that within the same geom_ab_line by giving the intercept a vector. So we'll do minus 1951 and minus 1971, and there is the bottom edge, okay? And so now we want to dash the line, and we can do that with the line type argument here in geom_ab_line. We'll do line type equals dashed, and so that gets a dash. I feel like their dashes are a lot closer to each other. So there's another line type related to dashed, which would be long dash. So that's long dash. I think those dashes are a little bit longer than what they have. I really only have 2 choices here, dashed and long dash. There's also like dotted and dash dotted and things like that, but I think what we want is the dashed. I'm gonna make this line a bit more narrow, and so we can do that back up here with line width. So we'll do line width equals, let's say 0.25. I think that's pretty good. I'm gonna stick with that. And you know what? I think that does actually, now that I see it with the thinner line, that does a pretty good job of replicating what they have for their lines. Now what I'd like to do is go ahead and add this men born from 1951 to 1970. So to do that, I'm gonna add an annotate function because it's only 1 bit of text I'm gonna add. So we'll do annotate geom equals text. We'll do family equals Franklin. All right, and then we need an X position, a Y position, and a label. So label is gonna be men born from 1951 to 1970. The X, if I bring this grid line down, that is between 2005 and 2006. I'm gonna say 2005.5. And then our Y is centered right there, and that's at, I'd say, 31, okay? So I'm gonna say 31 too. Get an extra space in there. Now I want this to be left justified on 2005.5, so we'll do hjust equals 0. And I need to add a plus to the end here. And there we go. We now have our men born from 1951 to 1970 in ours. The font seems a little bit big compared to theirs. So let's go ahead and bring that down a bit. And so we can do that here. We'll do size, let's say 10. I don't know what the default size is. I should learn that someday. Size.unit equals PT. And maybe it could come down to say 9. So I think that's a pretty good placement. Now let's go ahead and add the titles and the caption. So again, the title is going to be this drug deaths in Chicago among black men. And we already started a labs function up here. So we'll go ahead and do title equals that. We also want to add a caption, and I'll go ahead and copy this, plop that in, get everything indented properly here. So we're going to have a couple things that we need to do to the title. So let's start by getting it to be left justified on the plot rather than on the panel. And so to do that, we'll go ahead in here and we'll do plot.title.position equals plot. Now we have it left justified. Awesome. Let's also go ahead and now modify the plot.title. For the title, we'll do element markdown. And I'm going to use element markdown because I'm going to have bold and regular font. But to use element markdown, you'd come back to the top here and do library ggtext, get that loaded. Here then in plot title, I'm going to do family equals Franklin. And also I'm going to modify my title to have bold around drug deaths and black men. Oh, and I put 1 star, which is italics, rather than 2 stars, which is bold. So let's go ahead and add that back. All right, so 2 stars now. And that gets us our nice bold font, which is great. We need to shrink the size of the font though, right? So to do that, we can come back up into element markdown and we'll do size equals, say, 10. So kind of putting those Ds next to each other, they look about the same size. I'm happy with that size of font. We'll worry about the margin at the top here in a minute. Let's now think about the caption at the bottom. So we'll do plot.caption.position, and we'll set that for plot. That doesn't change because it's right justified, so we need to left justify it, and we'll do plot.caption equals element text. We'll do hjust equals 0, family equals Franklin, and then let's go ahead and do color equals gray. So it can be a darker gray, but also the font is a little bit too big. So let's go ahead and do, say, gray 30, and we'll put that on another line, and we'll do size equals 8. Okay, so I think that's a pretty good font color. Let's make it a little bit smaller still. So we'll go ahead and do 6. All right, let's bump it up to 7, and we'll call it good. I think that's great. So now let's turn our attention to our axes. And let's start at the x-axis because it's at the bottom and that's where my eyes are already pointing, looking at the caption. All right, so that goes every 5 years from 1990 to 2020. So again, back up here, I'll put this with my scale fill gradient right below it. I'll do scale x continuous. We'll do breaks equals, I'll do a seek function to go from 1990 to 2020 by 5. So that gets us our years at the bottom. And I realize that I'm going to be doing this family equals Franklin for everything. So I may as well come up to the top of theme and do text equals element text, family equals Franklin. And then I don't need to worry about saying family equals Franklin everywhere here in theme, because that's the only font that I'm going to be working with, right? So that'll clean it up and that'll prevent me from forgetting to use family Franklin somewhere here in theme, because I will, because that's just the way my mind works. So let's go ahead and shrink the size of the font because that's a bit too big. And so we'll add down here now, axis.text.x equals element text. Let's do size equals 6. Okay, that's too small. Let's take that up to say 7. And I think that's pretty good. So this is a very minor point, but my tick mark is, I think, is shorter and fatter than theirs. We could do axis.ticks.length.x. We can do unit, and I really don't know what the unit is already, so we'll do 5 and start there with points. Okay, that's close, but too long. So let's go ahead and take that down to 4. And then while I'm here, I'll do axis.ticks.x equals element line, and I'll do line width. Let's do 0.2. So now looking at this, I think my tick might be a little too long. So I'll see if I can do 3.5. I'm going to call that perfect. All right. So now I'm going to do the y-axis. And looking at this, I think the font on their y-axis and x-axis is the same. I also think the ticks are the same. So I'm going to go ahead and remove this .x. And so removing the .x will get the axis text, ticks length, and ticks to be the same both on the x and y axis. And yeah, I think that looks pretty good. We need to add more ages. So we go every 20 years, and we also have a 0. So we want to start at 10 and go up to 80. So we'll come back up here to scale X continuous, and we'll scale Y continuous. We'll do breaks equals seek 10 to 80 by 10, and that's entered in. I think that looks pretty good. One thing I notice is that there's a little space between their tick and the heat map itself, whereas ours goes right up to the heat map. It's almost like their tick has a margin around it. And so I can't add a margin, but what I can add is I can add a smidge of a year to the x-axis. And so if I come back up here to scale X continuous, I can do limits equals, so the first year is 1989, and the rectangle, the tile, is half a year. So it would take us back to 1988.5. So let's go back to like 1988.4, and then we'll put in NA to let it set the upper bound. And so I get a gap, but I'm also seeing the background's gray kind of show through here. So I think we're getting close. So we'll do panel.grid equals element blank, and we'll do panel.background equals element blank to remove the grid lines, which I don't think we really need to do that, but also to remove the background color. And so now we don't see the gray background, and it looks like there is a space around our tick mark, which is great. Now what I want to do is worry about this age and get the age to be up here above the 80 at the kind of the top edge of the plot. And so I'm going to go ahead and remove the y-axis title, and instead I'm going to put it up here using annotate. And so it's good that I did clip equals off within chord Cartesian, because now I can plot it up here without any ill effects. All right, so again, we're going to come back up to labs, and we'll do y equals null. That gets rid of the y-axis title. And so now we want to put in age up here. And so let's go ahead back up here where we had our other annotate. And we could do one annotate function, but vectorizing everything. But these two labels, the men born between 1951 and 1970 and age, are pretty different things. So I'm going to keep them apart just for my own mental clarity. So again, we'll do annotate geom equals text, family equals Franklin, and then we'll do x equals, and I'm going to do 1988, and my y, I'm going to do 84. We're going to have to fiddle with these values here, but we'll get there. We'll do label equals age, and that was in all caps, I believe. And then we'll do size equals 8, and size.unit equals points. Let's see what this looks like. All right, so I got a warning that it removed the one row. So I said that thing about clip, and it still complained about removing it. And I think that's because I have my x-axis limits in scale X continuous. So I'm going to pull this out of here and instead put it in chord Cartesian. And so again, what scale X and scale Y continuous do is they remove any data that's outside of the limits, and they give you a warning before doing any type of summary statistics. So this is, think about things like a box plot or something like that, whereas chord Cartesian leaves the data, but decides whether or not to show it based on the value of clip. So here we'll go ahead and put xlim. Now let's see what we get. So no warning messages, and we see we have age up here. And so we need to shrink the size a little bit and probably move it to the left and down. Let's go ahead and make that say 6. And let's go to 1987, and let's do 83.5. So I think the font size is pretty good. We probably want to go back to the right and up a little bit. So 83.75 and 1987.25. I think I can move age up just a smidge. Thanks for entertaining me. So let's go up to 83.9. So I think that's good. Something I'm noticing that I've commented on the past, I think the default color of the axis text is a gray rather than black. So let's go ahead into axis text here, and we'll do color equals black. And so yeah, that's better. That's black. Now what I want to do is the finishing touch of worrying about the margins, right? And so there's definitely a bit of a margin difference on the top and on the right and on the bottom, right? And on the left. So all the way around, we need to add some margin space. So we'll go ahead in here and do plot.margin equals margin. And so let's do like 5 all the way around. see what that looks like, and then we can adjust each of them individually. Let's start at the top. Let's increase the margin a little bit. So again, it goes TRBL, so top, right, bottom, left. Let's go up to 8, perfect. And then right, we need to add a smidge, so let's take that up to 8 as well. Great, we're on a roll here. And then the bottom, let's go ahead. I think that might need to go up a little bit higher, so let's take that up to say 10, good. And then on the left, let's go ahead and increase that also to say 10. And just eyeballing it, I think that looks pretty good too. One thing I haven't paid attention to is the position of the legend, and that actually looks exactly in the right place. So this looks great. One final thing that I want to experiment with here with you all is that my fonts always seem a little bit different than their fonts. And I definitely have the same Franklin font, but it just seems like mine isn't as full, doesn't have as much weight as theirs does. And so someone commented to me on a previous episode that when I use Font Add Google, I can specify the weight. And so yeah, so the regular weight is 400. So if I up that, then I can maybe make my regular font seem a bit stronger, right? And I could also adjust the bold weight. So let's go ahead and copy this in here into my Font Add Google. And let's go ahead and up this to say 600. Yeah, so that's definitely more bold. I think that's too much. So let's go ahead and take that down to 500. Again, the default was 400. And I think that looks pretty good. I like that. But I noticed that like this title, The Men Born from 1951 to 1970, is stronger than theirs. Also, In Chicago Among is stronger than theirs. So I wonder if we can make two font families that are the same font, but slightly different weight. So I'm going to call this Franklin Thin, and we'll make that, say, 300. So the stuff I want to make the Franklin Thin would be this text, The Men Born, right? And so we'll come in here and do Franklin underscore thin. And then the title, I want the default regular to be the thin, right? And so here then we'll go ahead and add in here family equals Franklin Thin. I don't know what that's going to do with the bold, but actually it should use the same bold weight because I didn't change that argument in the Font Add Google. Awesome, that did it. So we can see that it made the In Chicago Among a thinner font, not as much weight, but still kept the bold of the drug deaths in Chicago among black men. Cool. One final itty bitty detail I notice is that the top edge of my plot and their plot is a little bit off. So I think I need a bottom margin to my title. So hopefully this doesn't send me down a rabbit hole. So back up here in plot title, we'll do margin on B. Let's go ahead and put in 5 and see what we get. And I think that shrunk it actually. So let's go ahead and increase that to say 8. Perfect. You know what? I'm going to have a hard time differentiating between my version and their version. I think this looks pretty cool. I've really enjoyed working on this project with you all to try to extract the data from the original heat map and then go about recreating the heat map here in R using ggplot2. I've really enjoyed this and really like this look and kind of playing with all of the different theme settings to get it to match what they had in their original. Well, let me know what you think about this. Let me know what you think of heat maps and their strengths and weaknesses. Are there any cool heat maps out there in the wild that you've seen that you really like, or perhaps you just really hate? Let me know. Send me an email or put a comment down below. Again, all of the code that I've generated here today is available at a blog post down below that's linked in the description. Check it out, work through it, experiment with it, and see if you can't recreate what I've done or perhaps make my code even better. Or what would be even more fantastic would be to adapt it to your own particular needs. That would just be awesome if you could do that. Anyway, thanks again for watching. Please tell your friends about what we're doing here, and I'll see you next time for another episode of Code Club.